What's up, everyone? Welcome to a Google Cloud Security Showcase, a special web series where we'll focus on security use cases that customers like you can solve with Google Cloud. My name is Ahmad Robinson, and I'm a Cloud Security Architect at Google Cloud. Today, we're focusing on Privileged Access Manager, or PAM for short, and how this plays a critical role in managing privilege escalation during high-stakes incidents, like a P1 or a break glass scenario. So what's the deal with PAM? Well, as you know, in cloud computing, we can't just hand out admin rights like candy. Broad permissions can lead to unintended changes, or worse, they can open the door to attacks if the account is compromised. That's why we need to practice the principle of least privilege, giving cloud practitioners only the permissions they need when they need them and nothing more. It's about minimizing risks by limiting access. Essentially, you could do this in Google Cloud through a combination of IAM allow and deny policies to finely tune who can do what within your environment. However, there are scenarios, especially in production environments, where an engineer may suddenly require elevated permissions to troubleshoot an urgent issue, like that P1 we just talked about. Without PAM, an admin would have to, first of all, find the admin to grant the necessary access, then hope they remember to revoke it afterwards. Not only does this create unnecessary toil and potential delays, but it also opens the door to security risk if the access isn't managed properly. But instead of manually juggling permissions, this is where PAM comes in. PAM, or Privileged Access Manager, allows organizations to grant just-in-time access to Google Cloud resources. It enables pre-authorized users to self-elevate their privileges during emergencies with or without approvals, depending on the setup. And in this video, we'll cover a use case where the approvals aren't needed at all. Now, before we dive into the demo, let's quickly go over some key terms you'll come across when dealing with PAM. First, there's an entitlement. Typically, your IAM policy administrators will create these entitlements and assign a group of eligible users. Then we have the grant. Grants will be requested by your developers, cloud engineers, data analysts. Think of all the folks that typically perform the actual tasks. And finally, there's justification. Justification is the reason or explanation the user provides when requesting that elevated access, ensuring everything is well documented and accountable. Now that you have the core concept, let's set the stage for what we're about to dive into. Imagine we're working within a large financial services firm that relies on Google Cloud to manage its critical infrastructure. At the top of the hierarchy, we have an organization with a production folder that contains various projects. One of these projects has a few compute instances that are part of a managed instance group, or MIG for short. They are currently under heavy load with high CPU utilization. Now let's meet Raven. Raven is an awesome, skilled cloud engineer. Typically, she's part of the infrastructure team, where normally her role is limited to view only for configurations and monitoring performance, which is perfect for her day-to-day operations, but it's not enough when things start to go sideways. This week, however, Raven is also on call. This means she's dynamically part of a special group of engineers who are ready to step in and resolve issues whenever they arise. To enable quick action without compromising security, our firm has set up PAM entitlements specifically for these on-call engineers. This entitlement is tied to the production folder and allows Raven to request the compute admin role temporarily. It's designed to kick in during emergencies, like the one we're facing right now. So when Raven requests this temporary access, PAM steps in, granting her the necessary permissions to adjust the MIG and get those CPU levels back under control. And just like that, what was once a critical issue is now resolved. Now let's walk through what the PAM admin has previously set up. When the admin visited PAM for the first time, they provided the PAM service account with the necessary permissions. Next, the administrator configures an entitlement at the production folder level. Entitlements can be configured at the organization or the project level as well. However, the admin decided to go with the production folder to provide the on-call engineers with access to all projects within production. This entitlement allows on-call engineers like Raven to request compute admin privileges when needed. Because no approvals are required in this break glass scenario, the administrator has also configured notifications via email or pub/sub, along with potential cloud monitoring alerts, to ensure that the appropriate stakeholders are immediately notified whenever a grant is requested. This layer of visibility is critical for maintaining oversight, even in urgent situations like this one. Optionally, the administrator could have managed this entitlement through Terraform to be consistent with the rest of the infrastructure, but we'll continue through the console. All right, now let's follow Raven in her journey to resolve the issue at hand. She's now logged in, and notice how she doesn't have the ability to make compute changes. This is intentional, adhering to the principle of least privilege. But when it's time to act, Raven can request additional permissions through Pam. She proceeds to request a grant against the previously created entitlement, and because she's a very responsible engineer with the rest of her team watching, she chooses to request the least amount of time, which is 30 minutes. Raven then adds a justification, which includes the P1 ticket number, and the action she'll take in order to correct the issue at hand, and she ensures that her team is notified via email, and just like that, her request is complete. Again, since this is a break glass scenario, this entitlement has been set up to not require approvals before she is granted access to the role. Therefore, after a moment, she'll be granted access to this compute admin role. Next, let's look at what she does to resolve the issue. Raven continues on to the compute engine page, where she'll make the necessary changes to the appropriate instance group. But oh no, she still can't edit the group. No need to worry at all. Just give the page a refresh, and now she can edit with the compute admin role. Now let's take care of this issue. Now Raven verifies that her changes have taken effect and temporarily resolved the issue. Now Raven and the team have a little time until closing time, and they want to be prepared. So they craft a script of gcloud CLI commands that Raven will use to revert this change and ensure that the environment remains in sync with the infrastructure as code. Raven begins to run the script by first requesting access against the PAM entitlement once again. After confirming the grant, she proceeds to revert our earlier changes, then verifies this change. And now the infrastructure team can move forward with proposing a long-term plan for addressing this issue via infrastructure as code in a change window. Finally, every action Raven took is captured in the audit logs. PAM ensures there's a clear audit trail for compliance purposes, showing when and why privileges were escalated. And of course, we can see how these privileges were used in our standard cloud logs. So to wrap up, Privileged Access Manager is a powerful tool in Google Cloud's IAM suite, enabling you to strike a balance between security and operational agility. In situations where immediate action is required, PAM provides a controlled way to escalate permissions temporarily, ensuring that your cloud environment remains secure and compliant, even in the face of urgent situations like the one we just faced. In this video, we observed a use case where PAM can be used without approvals. But stay tuned for an upcoming video where we'll explore a use case where approvals would be required. Thanks for watching, and if you found this demo helpful, be sure to like, subscribe, and stay tuned for more insights from Google Cloud Security and best practices.